golf ball is at rest at the point A on horizontal ground. The ball's hit initially moves at an angle alpha to the ground. First hits the ground at the point B, where AB is 120 meters as shown in the figure, and the initial speed is u. We're asked, using the model, to show that u squared sine alpha cos alpha is 588. So let's look at A to B, and first of all, apply Suvat, saying up is positive. So we're resolving vertically. Now, when it hits the ground, it would have it's moved up and down, but the displacement will be 0. And then the original velocity, well, we can split u into components. Sorry, it's not force. Let me just try that again. Okay, so here I'll have u sine alpha vertically and u cos alpha horizontally. So this one is u sine alpha, and A is going to be minus 9.8. And we can create an equation, S equals ut plus a half at squared. So 0 is going to equal u sine alpha t. I'm going to put the t here. If you write alpha t, then it looks like you're also finding sine of t. You have to put it in a bracket. And then I'll be minusing 4.9 t squared. So I'll just put that to one side. And then still doing A to B. Look at Suvat horizontally. So here there is no acceleration, and actually our equation just becomes S equals ut. Okay, because half at squared disappears. So then the initial velocity horizontally is u cos alpha, and remember S is 120. So I'm going to get that 120 is equal to ut cos alpha. And now I can eliminate t. This is what you do when you're dealing with like the equation of motion for projectile motion. Then you use like a general coordinate x and y. Here we actually know that it's moved 120, 0. It's a little bit easier, but it's the same process. So t is going to equal 120 over u cos alpha. And then I can sub that in. So I can actually change it so these two are equal, and I can cancel out the t's because t is non-zero. Then I'm going to get u sine alpha equal to 120 times 4.9 all over u cos alpha. And that means u squared sine alpha cos alpha is 120 times 4.9, which ends up being 588. And we've proven the result. Then we're told the ball reaches a maximum height of 10 meters above the ground, and asked to show that u squared is 1960. So here's the maximum height. I'm going to label this point capital C. That is 10. So let's apply Suvat from AC. And I'll focus on the vertical direction because we know how far it's gone vertically, even though actually we know how far it's gone horizontally because we're going to get a parabola. To have to use that knowledge though, it would have moved 60. But I think we're just going to get this, that would give us the same equation that we had previously, in fact. So let's do Suvat vertically with this new knowledge. So S is equal to 10. U is still U, capital U sine alpha, but now we know that V is going to be 0. A is then still minus 9.8. I'm going to go through this in a couple of different ways. First up, this is how I did it. I decided to link the 4 that I know. I don't know what U or sine alpha is, but that's what I decided to go with. So V squared equals U squared plus 2AS. 0 equals U squared sine squared alpha minus 19.6 times 10, which means U squared sine squared alpha is equal to 196. Now we actually have simultaneous equations. You might think, what do we do from here? We're trying to show that u squared is 1960. So it's very similar. We just need to show that sine squared is equal to 1 over 10, in fact. Right, well, what we can do is take the u squared sine squared alpha and equal to 196 and divide it by the equation above. Because that, I know we're trying to find u squared, but that will temporarily eliminate u squared. And a sine alpha. This ends up being 1/3. So we get tan alpha equals 1/3, which is really good. You could try and do inverse tan of a third, but actually we just want sine alpha. So let's do it a different way. We can just use Pythagoras. We've got 1 and 3. 1 squared plus 3 squared square rooted is root 10. So that means sine alpha is going to be 1 over root 10. What happens if you put that in your calculator? Let's just check if it actually, you could do it that way. Tan inverse tan of a third and sine of that. Yeah, so it doesn't look like your calculator will deal with it. That's the problem with the same thing. So we're trying to get this exact answer. I guess when you square it, hold on, let me just try one more time. Like so so okay, it's remembered it there, but if I do inverse tan of a third and then do sine of that, like it doesn't know. But if I then squared it, I would get 1 over 10. I mean, maybe you're thinking like, can we just do that? But yeah, okay, if you're not sure, go for it. You might lose a mark. Um, this is a better approach. It's like when you're given tan alpha or sine alpha or cos alpha at the start of like a question with an angle, and you try and get the other ones, and you don't actually need to use your calculator. You just use some Pythagoras. So what this means is that sine squared alpha is 1 over 10, and therefore u squared times 1 over 10 is 196. So u squared is 1960 as required. An alternative method, actually, when we had u squared sine squared alpha is 196, is that I didn't think about it at the time, but we could have just square rooted u sine alpha. We know u and alpha are positive, so we just take the positive square root and it's going to equal 14. We could then sub that into here, which would give us 14 times u cos alpha is equal to 588. Then we could do 588 divided by 14 to give 42. So u cos alpha equals 42. And we could, I guess, then divide them, the two that I've just found, and again to get a third and go from there. So that'd be another option. Another option is to actually work out the time. So if you forget about u sine alpha for a minute, we've got 3 things that we know. So we can use I don't want to use u, so I can use s equals vt minus a half at squared. Give me 10 equals be minus, so 4.9 t squared. T squared will be 10 divided by 4.9, which is 100 over 49. So then t is 10 over 7. And from that, I could work out u. So v equals u plus at. So 0 equals u sine alpha. Then it'd be minus 9.8 times 10 over 7. I get minus 14. So again, I'd get u sine alpha equals 14 that way, which I can then do one of the method that I just talked about. I don't know, I feel like the way I did it is pretty good. Maybe maybe like this is a bit simpler to kind of understand than dividing the equations, but at the end of the day, all of these work. There's different routes to it to getting this u squared is 1960. So last little bit says in a refinement, air resistance is now included, and the motion of the ball from A to B is now modelled as that of a particle with initial speed of v. Refined models used to calculate v, which is going to be greater, u or v, giving a reason. So we've got the same conditions. It's still going 120 meters and it's still reaching a height of 10, which means because air resistance is going to be slowing it down, v is going to have to be larger to start with. V larger, need more speed to overcome air resistance. And state one further refinement to the model that could make the model more realistic. I went with it having dimensions. At the moment, it's a particle, whereas in reality, there's going to be spin on it and things like that. Here's a list of things you could write about. Wind, definitely, obviously, something relevant in golf. More accurate value of G, spin of the ball, size of the ball, shape of the ball, dimensions of the ball, not a particle. They're kind of all linked together, but one of those. Variable acceleration, surface area of the ball, humidity, allows wind resistance. Okay, you can't say air resistance, but you could say wind resistance or even rotational resistance. All right, well done on your efforts here.